Today we're going to start off with the next chapter of class 9 physics, that is force. Force is a quite easy chapter, but it covers lots of theory part. So you have to have better understanding through the questions based on this chapter. So let's begin. Force is not the first time this term is introduced to us. We have been introduced to this term in class 8 as well. So basically force is what? It is a push or pull. So whenever we define force, these two terms must come into your mind, that is push and pull. So whenever force is applied, either it is in the form of push or in the form of pull. For example, you are opening a door, you are pushing something, you are throwing something, you are pushing something, you are lifting something, or wherever you are doing certain actions, force is also always been applied in the form of push and pull. Now this push and pull can bring out various changes. Those changes you are quite aware of. So let's discuss one by one. Very first, it can change state of motion. Now what do you mean by state of motion? For example, an object is being kept stationary. Let's say a ball is kept on the ground. This ball is being kept on the ground, and then you just applied force on this ball. What will happen? The ball will start rolling. So ball will change its position or state from rest to motion. Correct? So this state change can be brought with the help of the force. Next example can be change in shape. Let's say you have a sponge in your hand. You just hold the sponge tight. What will happen? The shape of the sponge will change. Or simply just take a piece of paper from your notebook and just crumble it. Once you crumble it, again the shape is being changed, and again this time you applied your force. So this is the next thing which we can do with the help of force. Third, we can accelerate a moving object. Now what does accelerating a moving object means? For example, a ball is rolling. That rolling ball you just kick with your muscular force. What will happen? It will start rolling faster. So this is again an example of application of force. Or you are traveling in your car and then you see that the road is vacant. What do? You just press on the accelerator. Again the speed will increase. So with the force only we can accelerate a moving object. It's vice versa is also true. We can deaccelerate a moving object. And next is we can make a moving object come to rest. Now moving object rest means, well, let's say you are on the road and you are in your cycle or you are in your car or automobile and you just hit the brakes. What will happen? Once you hit the brake, your motion will be ceased. You will come to rest. So again, this example of force only. So these are few things which we can do with the help of force. Okay, do we have different types of forces? Yes, we do have. So let's discuss those two most basic classifications of the forces or basic division of the forces. We have balanced and unbalanced. Balanced forces and unbalanced forces. Now, balanced forces are those forces in which the net force is zero. Now, what do I mean by net force? I'll be just taking on that a little later. Unbalanced with the net force is non-zero. Okay, so just go back to now balanced term now. Let's say we have an object whose mass is capital M. Right? We are applying certain force. Let's denote the force by F1. So we are applying F1 force on the object from the left side. Okay, and we are applying F2 force on the same object from the right side. So we are just applying the forces of opposite nature in opposite direction. One force trying to push on the left, other trying to push on the right. Now if I say both these forces are equal, F1 is equivalent to F2, then what do you expect then? Are you expecting this object will move? Just think of it. F1 want to move it to the right, this wants to move it to the left, but both the forces are exactly same. So do we expect any type of motion here? The answer is no. The object will remain as it is. So this is an example of balanced force. So balanced force is what? Balanced force is when the net force acting on an object is zero. Or we can say when the force is not bringing any type of change in the object. Okay, just think of a little more examples of balanced forces. Have you been part of ever a tug of war match? Do you remember what happens there? We have a rope and we have two teams. Let's say team A and team B. Both the teams are having one task to pull the rope towards their direction. Now, if the forces exerted by both the teams are again exactly same, this rope will not move at all. This is again example of a balanced force. Another example we can take, let's say an object which is placed on the table. Now, since this object is placed on the table, but this object is not moving at all. Now, do you know that whenever you are placing something on the surface, it always acts a downward force. So, the downward force is the weight of the object. So, weight is acting downward, whereas a normal reaction, this term we'll discuss a little later in the upcoming chapters, this normal reaction will be acting upward. Both the forces are again same and the object is said to be balanced. So balanced forces are those forces in which the net force on the object is 0. Now let's move to the next one, that is the unbalanced force. So unbalanced is the vice versa of your balanced only, when the net force is non-zero. Let's take again the same example. This is your F1 and this is your F2. But this time F2 is greater than F1. Previously both the forces were exactly same. But this time we have F2 whose value is greater than F1. So what do you expect now? We expect a motion here. Motion in which direction? The direction in which more force has been exerted. So as you can see, F2 is greater than F1. So object will start moving in the direction of F2. So you are thinking it right. This will be the new position. And will just keep on shifting as long as this F2 force is acting on the object. So I hope these two terms are quite clear now. F1 or F2, if both the forces are same, acting in opposite direction, then it will be example of balanced force. If they are unequal, example of unbalanced force. In terms of definition, balanced forces where the net force is 0 and unbalanced where the net force is non-zero. Alright, let's move on to the Newton's law now. In case you have any query or you want any specific expression or explanation, just drop a message in the comment section. We'll just try to answer it in our next class. Okay, now we're moving to the next part, that is the Newton's first law, or you can say the first law of this chapter. Sir Isaac Newton has given 3 laws for the forces. First we are talking right now, Newton's first law. First law. This first law is a quite important law as well, as it governs everything. So first law is what? It states that an object will continue its state of rest or motion until and unless some external force is applied on it. Let's break it down now. So what we are trying to say here is, we are trying to say that if you are having certain object, let's say this object whose name is O, whose mass is M. This M size mass object is placed. This object will remain in its position forever. Till when? Till we apply certain force externally to change its state. So if you want to change the state of the object either from rest, or we'll take on the motion later on, this object was at rest. So if the object is at rest and you want to bring it into motion, then you have to apply the force externally. If you miss the force, this object will remain where it is. Now let's discuss if the object is in motion. Let's say this object of mass m is moving with velocity 4 meters per second. Now this object will continue to move with the same velocity unless it is acted upon by a certain force. Means this object will continue its motion till infinity. But now you will say that this object will cease its motion after some time. Yeah, you are correct. But why? Because there is another force, that is force of friction, which is trying to oppose the motion. But if we take the same object into the space and let it move, then this object will move infinitely. So this is what your Newton's first law states, that every object continues its state of rest or motion until and unless it is acted upon by some external force. Now, there is another law which is connected to first law only, that is law of inertia. Now, what does law of inertia states? Law of inertia. Law of inertia is that object is having the ability to oppose the change, or the tendency of an object to resist the change is known as the inertia. So inertia can be of three types, that is inertia of motion, inertia of rest, and inertia of direction. Inertia of motion, object wants to be in motion only. Inertia of rest, object wants to remain in the state of rest only. Inertia of direction, where object wants to be in that particular direction only. Now all these three inertias we will discuss in detail in our next class. Till then, just revise today's topics.